I can't put one mark of congruency on all those segments because I don't know if they're all congruent to one another. I have to clearly show the different corresponding pairs of parts. Now let's do the angles. What we've seen before in this class, and the notation that I'm most likely going to use in this class is starting off with one mark of congruency for these angles, these arcs. And then if I want to differentiate between that pair of angles and this pair of angles, I just add another arc, and I put 2, and then I would put 3, and then I would put 4. That's what we have seen, that's what I've used. However, there's some textbooks, there's some worksheets, there's some tests out there where they're going to use a different notation but means the exact same thing. What they choose to do is they put one arc in every single angle. They put one arc in every single angle, but then the way that they differentiate is they add like these tick marks that are on these arcs. So they say, okay, angle A is corresponding congruent with angle E. And then angle C, they put 2 tick marks on that arc, is congruent corresponding to angle G, and then angle D is congruent corresponding with H, angle H. And they put 3 of those tick marks on that arc. It means the same exact thing. They're just telling their audience, they're telling the readers that these are 4 different pairs of congruent angles. So you need to be able to understand both types of notation for congruent angles. Any questions on how to identify corresponding parts or the notation? We good on this? Alright. Last class we should have talked about these 4 acronyms that I have written on the board here. Did we copy the notes down all the way to HL? We may have not discussed them in length, but we at least have these acronyms down. Okay, good. Today we're going to kind of dissect all of them, and I'll give you clues on what to look out for, so on and so forth, and then we're going to walk through that worksheet that I handed out last class, last time I saw you, which was almost 2 weeks ago on Wednesday. Let's push this to the side just a little bit. Okay. Do what? Okay, what we established last class was that we're trying to find the minimum information needed to prove that 2 triangles are the exact same size and the exact same shape. Well, we know that triangles are made up of how many different parts? What row?
Number 6.
How many parts? So if a quadrilateral had 8, then a triangle has 6. Okay. 3 interior angles and 3 sides, segments. So what we talked about last class was, is it truly necessary for us, for every single problem, if we're trying to prove that triangles are congruent, do we really have to show all 6 of the corresponding parts are congruent? Or is there like a minimum information that we need to prove that triangles are congruent? And we talked about it, and I think that we all came to the conclusion that we must have at least 3. Do you remember that? Okay, we started off with like 1. We said, okay, well, what if we only knew that 1 part was congruent? Well, obviously that's not enough information. We don't know anything else. And I said, well, let's force this angle to be a right angle. So now we have a side and we have an angle. Is that enough information? We said, well, no, because I can extend this side way out here and I can just make this guy really short. That's not enough information. So we said, well, what about 3 pieces of information? What if I force this segment to be a certain length? Well, now that we have 2 sides and an included angle, Well, then there's only one way I can connect that vertex to this vertex, which would make these two triangles have to be congruent. And so we said to ourselves, okay, we need 3 pieces of information. And then we listed all of the possibilities, all the different combinations of sides and angles that we could know about two triangles. So maybe we knew all 3 sides were congruent. Maybe we knew all 3 angles were congruent. Maybe we knew 2 sides and an angle. And we've got 2 of those options. So I'm going to go ahead and put stars next to these, because these are extremely similar. We got 2 sides and 1 angle that we know are congruent about these 2 triangles. And here, similar situation, kind of the same. 2 sides and an angle. Then, maybe we have 2 angles and a side. So, it's like this guy and this guy. Different placement of that side. Here, this is where the side is the included side. It's in between the 2 angles. This is where we have the non-included side, where the side that we know information about is not in between the 2 angles. And then we'll talk about this guy right here, what HL stands for in depth. But these are the possible combinations of 3 pieces of information that we know about 2 triangles. We need to figure out which ones work and how to identify when we have this information. Alrighty. So, as we go through these acronyms, you may need to add to your notes that we took last class, however you're comfortable. The first one, the acronym is SSS. I think that's pretty obvious that it stands for side, side, side. An example of this, and you don't have this, but you can look up at the board. An example of this would be like this. You may have this diagram on your test, where the triangles are not in the same orientation. Clearly, this guy is rotated a little bit and then reflected. So the triangles don't have to be in the same orientation. You just need to figure out what 3 pieces of information do I know about this triangle, and is that enough to prove that they are congruent? So what I'll do in class is I'll just identify what we have. This side is corresponding to that side, and this side is corresponding to that side, and this side is congruent and corresponding to that side. So I have the 3 corresponding sides are congruent of these 2 triangles, SSS. You should already have that written down in your notes. Now, did we say that this is sufficient information to prove that triangles are congruent? Yes, this is enough information, so this does work. We will call this the side, side, side triangle congruence theorem. And it states that if 2 triangles have all 3 corresponding sides are congruent, then that means that the triangles are congruent. Even though we didn't know anything about the 3 interior angles to begin with, that's okay. The 3 sides are enough information. And then we went to the next acronym, which was side, angle, side. An example of that would be like this. And again, in class, I would label these as such. And I would say, okay, this side is congruent and corresponding to that side because they both have 1 mark of congruency. And this side is corresponding and congruent to that side because there's 2 marks of congruency. And then this angle is corresponding to this angle. So I've identified my 3 pieces of information. I need to figure out, is this enough information, or is this an appropriate amount of information to prove that these triangles are congruent? Well, I know that I have 2 sides and 1 angle. So it's either going to be one of these theorems. One of them does prove that triangles are congruent, and one of them does not. So in order to figure out, well, which case do I have? Do I have side, angle, side, or do I have side, side, angle? Well, just like the acronym, you need to figure out, well, where is the angle located, the A, where is the A located with respect to the sides in the diagram? So you need to ask yourself, is the angle in between the 2 sides? Is it the included angle? Is it the angle that's being formed by those two sides? And that's what you should have written on your notes. Or is the angle one of the non-included angles? Is it not in between the two sides? And so for this case, where's the angle located? It's in between the two sides. It is the included angle. So that's how you would know for this guy, for this problem, you would use side angle side. Side angle side does prove that triangles are congruent. And so on a test or a quiz, you would write, yes, triangles are congruent. If we had the vertices labeled, like let's say this was A, B, C, and this was X, Y, and Z. If you had the vertices labeled, you not only would have to write yes or no, yes, triangles are congruent, you would also have to write a congruence statement. So I would have to say that triangle ABC is congruent to triangle, but letter order matters. So there's only one correct answer for this. If you choose to name the first triangle ABC, letter order matters. Which vertex in this other triangle is corresponding with vertex A? How do I know which letter to put first in this other triangle's name? It has to be X. Look at the sides that are creating this angle. It's this side here with 2 marks of congruency. So this side here. The other side that's forming angle A is the side that we don't know anything about. There's nothing on this. So it has to be angle A is corresponding with angle X. Which angle is corresponding with angle B? Y, because these angles are congruent, so I can clearly see that B is corresponding with Y. That one's easy. And then my last letter, obviously C is matching with Z. So you would write the triangle congruence statement, but then you have to justify, just like all of every single one of your quizzes and tests. You have to show your work, you have to explain why. So how do I know that these two triangles are congruent? Got to be one of these theorems that work, and we decided that these triangles are congruent by side angle side, because the angle that we knew that was congruent was in between the two congruent sides. It was that included angle. This is the bare minimum information I would need to see on a quiz or test or final to get 100% credit. Answering the question, yes or no, writing an appropriate triangle congruence statement with correct letter ordering, and then tell me why, justify your answer, what theorem. This is the bare minimum. And we're going to do this together on that worksheet, so if you're frantically writing this down right now, it's okay. Breathe. We're going to do this together many, 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 many times. So so that's when you have two sides and the included angle. However, what happens when you've got, so in this case, this is another example, another scenario where you have two congruent sides and one congruent angle. Okay, because we need to talk about this guy. We know this one's worked, we just did it. What happens if you have this side goes with that side, and this side goes with that side, and then this angle goes with this angle. So we have side-side angle, where you have two congruent sides and the non-included angle. Does this work in proving triangles are congruent? Is this sufficient enough information? And the answer is no. Side-side angle does not work. It does not produce congruent triangles. The easiest way of remembering this is side-side angle, this acronym. Well, all of these that we've talked about thus far, they're palindromes, so they're the same backwards as they are forwards. like race car, it's the same forward as it is backwards. What is this backwards? Think it to yourself.